Good morning. Welcome to episode number 54 of the Zoomtown experiment. We've actually been going over a year already. Today's video, we're going to revisit a suggested idea from another viewer a few months back. I believe his name was Steve Woodgate, and he suggests that I look into a sensor from Useful Sensors, the name of the company. And here's the little box that it came in, and I'm still just digging the heck out of that little box. It's from the company Useful Sensors. It's called the Tiny Code Reader, and its ability is to read QR codes such as this one. And the purpose of that is to give us a way somewhere or anywhere on Zoomtown for the Tiny Code Reader to read the QR code. And with that data, I can associate it with a very specific position as to where the Zoomie is and have incredible capability with regard to localization. Localization meaning that the Zoomie knows where it is very precisely. It will then communicate that back to the scheduler so that on the layout there with the sprite following along, they're very accurate to each other, meaning the real world is very close to the simulated world in the scheduler software. Now, why am I revisiting that? Well, if you watched last week's video, or the last video, episode 53, I talked greatly and extensively about all the problems with keeping track of positions, having reliability of knowing where the Zoomie is within the Zoomtown arena, etc. And that is critical, absolutely critical for this experiment to move forward. If the Zoomie can't keep track of where it is or find itself within a location, the experiment's doomed to fail before it even starts. So this has to be resolved now. Also, at this point, if you watched last week's video, you'll know that I've mentioned that the code is most probably being rewritten. I'm looking at everything from a completely different perspective in hopes I can keep this whole crazy project moving forward. Here on the slide presentation, I'm not going to go through and read all of it. It's more notes for me to know what to talk about, but I've just explained what our problem is that we're addressing. And the bottom element here in this area here is another aspect that I have to fight with constantly, and it's dealing with multiple coordinate systems. Again, that was covered in the previous video, and it has to do with these two coordinate systems. 1 and 2 are related to how the Zoomie looks at things, and coordinate system number 3 is how the scheduler has to look at it. And I need those to be perfectly in sync at all times. Now, early problems that I had with the Tiny Code Reader, there were numerous ones. And I didn't want to just list all of them. I just thought I'd kind of focus on the ones that were a problem, that were very at the time, insurmountable, we'll say. The Tiny Code Reader updates approximately every 200 milliseconds, which is about 1.8 inches or 46 millimeters of travel. I could drive right past one of those QR codes and never even see it if I'm going at full speed. And of course, that has to do with the field of view of the sensor. We'll get into more of that in a little bit. Reliability of reading the codes was very poor in my first experiments, and that was moving very slowly. I could not get consistent readings. Didn't really spend a lot of time trying to figure it out at that time, but I just chalked it up to most likely this will not work for our application. Slow reading, it does take up to 6 milliseconds to get a reading. And if you remember and been following along, I need my main loop to run even faster than that. So this would slow things down. Is it a big problem in the big picture? At this point, that's being reconsidered. Mechanical mounting of the sensor to the whole Zoomy is going to be a challenge. It's not something I've overcome yet. In fact, this bracket I'm just treating as a prototype. I don't want it like this. The other side of the whole problem is I have 4 wires for the tiny code reader and then 2 wires that have to get to the LED. And I'll talk about that in a little bit as well. So I need to be able to get 6 wires out to the sensor and its supporting LED and get the body over this. And that'll be an engineering challenge, kind of one I'm looking forward to. But right now my brain's all wrapped around the logic and programming and making things work. So that's on the back burner for now. The other issue is this sensor is rather expensive compared to all the other ones on the Zoomy at $7. I had mentioned that the last time, but I've got some very generous viewers and they've been helping me out quite a bit with that super thanks function with donations and so forth, and just viewers watching. I think I get a half a penny for every view somebody watches, so all of that helps fund this experiment. Now here are some of the solutions that I'm talking about with regard to this. The updating every 200 milliseconds has to do with that field of view of the sensor. So earlier on, I was mounting the sensor closer toward the bottom. And like with any camera, the closer you get to the lens, the less field of view you have. And I'm keeping this up at the top of it, and I can go a little bit higher depending how I finally work out the final mounting of it. But the further I am away, and right now I'm at the far edge of what they recommend as far as distance from the sensor to where the QR code would be. So right now I got a pretty good balance there. I also tinkered around with the size of the QR code to get it large enough so that it fits in that field of view, and I can maybe even get a couple of pictures of it as it's passing over. So all this, where I mount the camera, and it's kind of hard to see too, but you might notice that the camera is slightly tilted this way. And that gives it a chance to look forward a little bit better. As I recall, and going by approximation, I think I can see this far forward, all the way out to here, and then anywhere in between on that. And that's, again, with all of what we just discussed. So that kind of solved that issue. Reliability of reading the codes was very poor. Could not get readings from the sensor at all times. And without a known cause or reason, a substantial amount of testing had to go into figuring all of this out. And ultimately, I can't see what the sensor sees. Unlike an AI camera or a normal camera on a computer, you can look through the lens of that camera because the Raspberry Pi or your computer gives you all the tools to do that. This sensor doesn't provide that. So I got to guess what I think the problem was. And I got lucky with some guesses. Ultimately, the reason why it couldn't read had to do with contrast and how it's finding the QR code relative to the background or surrounding area. And it wasn't just as simple as raising the camera up so we could see more of it. Turns out my overhead lighting that I've got above Zoomtown here, it looks like fluorescent light fixtures, 2 4-foot ones with 4 bulbs total on each. And they're LED. For whatever reason, when those are on, my ability to read that QR code drops dramatically, very dramatically, so much so to the point where it really doesn't work. So that was one of the weird discoveries, and it was purely by accident that I found it. I had forgot to turn that bank of lights on when I went about experimenting, and everything was working great. I took a break, came back, turned the lights on, nothing was working again. And so I backtracked and figured that out. I also needed to have better consistent lighting then, because as you can imagine, even with this large overcast lighting up above, and it casts over the table or Zoomtown very evenly, the angle and the shadows can really mess with you. And that's where this LED came into play. It's a fairly high-powered LED, somewhere I think maybe going by memory, I think it's about a half a watt. So it's throwing out a substantial amount of light on the table, or in our case on Zoomtown. So I got the lighting kind of figured out, but then it still wasn't behaving good. And what it was, and I'll get a different camera view that I'll throw in here to help explain this. As I'm moving along where the camera, the sensor, tiny code reader, is looking, I would go from dark road sections, that dark gray background for the road, and then I would hit the sensor or the QR code, which is on a white background, and then the QR code and then some numbers under it. Well, I didn't know exactly what was happening, but what I did see was a lot of digital cameras and automatic exposure. You'll see the brightness levels change. Often you'll see it, and of course today it won't do it, but when I pass my hand over the workbench camera, sometimes it'll get brighter and dimmer, etc. And I suspect that's what was happening. So instead of putting the QR code directly on the road surface, I went to the hardware store, picked up a roll of this tan colored, it's as close to white as I could get, masking tape. And I think it's 18 millimeters wide, so a little over 3/4 of an inch. I put that down, and then I put the QR code on it like such. So the camera's constantly seeing this color, and the transition from this color to this color is very minimal in difference. And that made all the difference in the world. So there was a lot of experimenting that I went through to get much better reliability of reading. And it's paying off so far. The slow reading, it can take up to 6 milliseconds to get them. Nothing I can do about that. I can't change that. So how can I accommodate that? And that's what I focused on for a solution. And I can play games with my main loop, being deterministic, and probably come up with a clever way of doing this every other cycle or something like that. At this point, I'm not going to put a lot of time and effort into it. And there's the possibility it really won't matter. And I'm going to bank on that for now and not waste time coming up with a solution to that. Mechanical mounting, as I mentioned, this has to all be engineered out. This is purely conceptual, but I do like the location and height of the tiny code reader relative to the Zoomy and to the work surface. And even more importantly, as the Zoomy's going along the road, it's following the guidelines, right? And then out here, I've got a little barrier wall that's just sticks up, about a ½ inch or 13 millimeters from the road surface. That way he doesn't drive off and die. So I've got to get this positioned consistently in that area over there. And it will actually drive over the QR code as it's passing by. Another thing that I came up with on that, because I'll have the QR code actually pass under the Zoomy, eventually that, these are printed on a laser printer, eventually that's going to wear down and get marred up. So my first thought is I would put a clear tape over it. Well, that was not a good thing because it was glossy. It wasn't the frosted kind that you typically use for wrapping Christmas presents. Being that it's close to Christmas time, I just happened to have a roll of that around, put it on there, and that frosted clear tape didn't affect the ability of the camera to read it. So what it essentially did was took away glares from the glossy surface tape. So that's how I'll protect that in use. But the mounting of all this and how to fit it in the body, that's a work in progress, and I'm looking forward to that one. Cost of the unit is expensive at approximately $7. However, at this point, I'm probably $1,200–$1,500 into all the components for all the zoomies and some of the other materials. It's probably a lot more than that, but to feel good about it, that's what I'm saying. I got invested in it. So if I put another $150–$200 into it for all these tiny code readers, and I get success from that, it's worth it. That gives me the value in return. Plus, as I mentioned, I've got a great audience, all you folks that have been following along. I've gotten views out of that. You've watched other videos. That gets me a little revenue and some generous donations through the super thanks function. It all helps, and it makes me feel good with, thanks to Steve, I'm going to go ahead with this and really charge forward. So the rest of the tiny code sensors will probably be placed. The order for that will be placed tomorrow, and then I'll have them all on hand when I build the rest of the zoomies. Now, unfortunately, this is getting really long, but we're kind of on the far side of it right now. I do want to still cover over conceptually how this looks with some more graphics and go over the code and talk a little bit more about the layout. But this kind of represents the east end, or the right side of the layout. I got to turn 90 so it would fit the screen better. But as you can imagine, the zoomie comes along this road, makes the turn around. Now right here is the 0 point of the road. Now the X and Y coordinate in Zoomtown could be any X or Y value relative to the start point of a road. The magnet on the left side of the guide, or the inch markers, these are those 1 inch or these 1/4 inch wide black tape markers that are exactly 1 inch, 25.4 millimeters apart. The one that's on the left here, looking in the direction of travel, that's the 0 set marker, and that is, of course, at 1 inches. Another big story there. The other marker on the right side of that 1/4 inch wide tape, my inch marker tapes, is the preset position marker. And what I'm doing, I'm combining this, the 0 set, the preset, and the QR code all into one combined event. And that will make a lot of sense here in a minute. But just backing up for a moment, if I'm parked in this particular driveway, as you can imagine, I'm going to back up, turn around, and then I'm going to head in this direction. Well, as soon as I see a QR code, I record that position. I just leave it in the register, the memory, the variable. And then as soon as I hit this point with the magnet on the right side in the picture, red dot, and this bar, that's when I'll make the association to those 3 elements and record or update position right at that spot. But every time I enter the road, I have to have some way of saying you are here. We've probably all seen them on maps, the little dot that says you are here. That's exactly what we're duplicating here with the QR codes. And they're going to be all over this layout by the time we get into the actual experimentation mode. Here's how this will look. I'm zoomed in a lot further. I'm moving my zoomie along, and you will see that the QR code will contain the distance from 0 to here. It will contain the X and Y position from the origin of Zoomtown, which is the upper left-hand corner or far left corner of the whole city. and then the actual road number that we're currently driving on. And that way I got a lot of information to tie everything together as to exactly where the Zoomy is. Now, how do I get it so accurate? Because let's face it, I could be seeing this QR code anywhere within 2, 3, 4 inches of travel. Well, how do I get that down to a 0.5 millimeter of position? Well, in the code, and we've had this in there for a very long time, as I'm driving along, my photoreflective sensors are looking for this black line and a very specific point on the black line. As soon as the sensor passes over the line and it transitions from, we'll call it on to off, as soon as it does that, I know exactly where that is relative with the Zoomy to the layout. I know where that transition is very accurately. And if I'm seeing a preset magnet, a preset sensor, and I've got data in the QR code register, I put all 3 of those together and I know I'm exactly at that point. So the transition to off on that point is very accurate. And I did some pretty detailed testing on that early on when I was just using the magnet and the black tape, and I swear it was less than a 0.5 millimeter of deviation. So I was really, really pleased with that overall. Now, another really cool feature that I can incorporate into this entire process, should the QR code work out, is for the robot, the Zoomy, to determine where it is at the start of an experiment or a start of a simulation run. Here is our Zoomy, the green arrow, labeled Zoomy, parked in a driveway. In that driveway is going to be a QR code. Now I could take a Zoomy, place it in any driveway. And at the start of the simulation, I will have a routine that will take the Zoomy, back it up a couple of inches, scan the QR code, and then pull back forward. When it does that, it will know exactly where it is, and it can report that back to the scheduler. That is awesome. To do that, where I had designed the software and scheduler, I would have to manually go through, look at each of the 16 Zoomies, and then position them on the layout. Not that difficult of a task, but you can imagine doing that 10, 15 times when you're doing debugging, testing, or even running experiments. It's tedious and error prone. So this was another huge benefit with switching back to that thinking the QR code is my savior in this process. So thanks again, Steve. All right, now what we'll do, I'll talk a little bit over on the layout, kind of giving you an idea what things look like there. That'll be on another camera, and you'll get a feel for how this will work and how it'll look. This would be a normal parking position for the driveway. It'd be about that close to the barrier, as you can see in here. So at the start of the whole experiment, the Zoomies one by one will be told to back up a couple inches. The sensor can read the QR code. Once it does that, it will pull back forward, line up perfectly at the edge of that tape, and report its X and Y location relative to the entire Zoom town. You can see here how well the LED light illuminates the surface very consistently. It's kind of like having headlights on the Zoomy. He brightens up the entire area right in front of it. But in our case here, our example, you can see I've got that masking tape background there, QR codes on top of it. As we come around, probably right about here is where it will actually read the code. And when it gets up to the 0 set marker, it will implement that positional information into its data. Moving along, it'll read that QR code in advance, and then once it actually gets to that point where the preset magnet is and the inch marker, it will again update its current position, and broadcast it through to the scheduler. And that would continue all along the road. Likewise, when we back out, we will back out, pivot turn, and start driving forward, and that same process would happen. Further showing what this will look like as we're coming along the road here, you see how well it is lit up, reading the QR code, and then right there is the preset magnet, the inch marker that will activate it, and the process just continues over and over again. Again, so far, it's working really reliable. So, in the real world, relative to what I'm showing up here in the graphics, makes sense, I hope. So far, all testing is proving it to be pretty good. Now we'll just wrap this up. I'll take a quick review of the code. I might have reviewed this in the previous time I worked with the QR code, but it should only take us a minute or two to go over what the program actually looks like. Now I won't show you the rest of the program. This is just a function or a couple of functions built or embodied in the rest of my mess, as I'm calling it lately. Here's a function where we're going to call this one from another function after we read it. And this basically will just take the message, break it out into useful bits of information. So let's go down and read it first. I will call this check QR code as frequently as I can within the main loop and not overburden the system and waste all my time just checking this. I got to tend to other tasks. I've got a global variable, the message counter. I want to try to keep track of that. That may be more important later on. But this is the actual code right here that does the reading. There is some setup for it earlier on in the whole program where I define these variables and, of course, get the interface going for it. It's I²C. But it will read that QR code. If there's a QR code there, it'll follow these parameters to make the read and then store it in this message bytes variable right here. Then from there, because I don't always get a perfect QR code reading, I will take and create a message string from the message bytes and decode all of that using the UTF-8 decode process. And then from there, I make a test. If the length of the string is greater than 10 characters, I'm going to treat it as probably a good QR code. I'll increment my code QR message counter code, and then I'm going to unpack it, which is here. You'll notice I'm using global variables because I need to preserve these values. When I read it, I may not necessarily be at the exact point where the preset or zero set magnet is and at the transition off of that 1-inch tape. So I need to preserve it. But just going through using the find function to find the spaces which separate all the different values on here. Hopefully this will show up on the camera. If I can hold still enough. This would have been 28 for 28 inches up from 0 on that road section. It is that the X coordinate 72 inches, the Y coordinate of 36.5 inches, and it's on road number 18. So it's got four sections or pieces of data on it, and we just extract that out by looking for the blank space between each of them. And we put those into these variables so that they're accessible everywhere. Nothing really fancy there. That's at this point. I got some debugging stuff here that I print out data as I'm working through applying that data. And then if there's an exception, I print myself out a message down here on the shell so I can understand what's going on. That's the bulk of the code. It's very brief, not a lot going on there. A lot of it's actually debugging information. So all around, it's simple, It's been working really good, and I'm really starting to dig it. So hopefully this all plays out in the next few weeks when I bring all the new pieces of the puzzle together and we can move forward with the project. So with that, I think I'm going to wrap up this QR or Tiny Code Reader QR code discussion. It will be probably talked about again. If you want to know more about it, please let me know in the comments below, or if you got any questions about what we talked about and its implementation, let me know in the comments below. So that'll wrap it up for this issue or this episode. I believe our next episode is going to be a very high-level overview of the current new rewritten program of the Zoomy Control program. So all this code, if it's going to work the way I'm currently dealing with it and it's acceptable when I get there, that'll be the subject of that next video. Why it's different and what's different about it. I hope to see you then. Take care, happy programming, and thanks for watching.